In this video, I am going to solve the second problem from chapter 17, Waves Part 2. What is the intensity at radial distances A 2.5 meter and B 6 meter from an isotropic point source of sound that emits energy at a rate 12 watt, assuming no energy absorption by the surrounding air? So this question also have two subdivision. In the first part, we are going to calculate the intensity of the sound waves at a radial distance of 2.5 meter. So let's we take this circle. Isotropic means the source will emit the energy in all directions equally, right? So here it looks like a sphere-like structure. So the radius is mentioned, which is nothing but the radial distance is nothing but the radius here, right? So from the center throughout all the points, you will get the same distance as 2.5 meter. So 2.5 meter, let's we take this is R1, right? And likewise, in the second question, in the second part, we are going to consider the radial distance of 6 meter. So that means this is R2 value 6 meter. So for this 2.5 meter and 6 meter, we are going to calculate what should be the intensity of the sound wave. As we already studied in the theory, for calculating the intensity, we studied the rule I, which is equal to the power over area, right? And here they mentioned the power also. What is the power? For two cases, you have to consider the same power as 12 watt, right? So now I have to substitute this value here. The most important thing, it looks like a sphere, right? So we have to consider what should be the surface area of the sphere. So I have to apply the rule for the surface area of the sphere. So the surface area of the sphere is given by the rule 4 pi r square, right? So I have to take this formula, I have to substitute here. So I take R1 because first of all I'm going to calculate the answer for the radial distance 2.5 meter, and after that I have to come for the distance 6 meter, right? So I'm going to take this, I'm going to substitute here. By that, this equation will become P over 4 pi R1 square, right? And here they mentioned the power as 12 watt over 4 multiplied by pi multiplied by R1 square, which is our radial distance 2.5 meter. So which is square, right? So we have to squaring this. So if you calculate, I got the answer as 12 over 4 pi 2.5 square as 0.1527, and the unit is watt per meter square. The unit for power is watt and the unit for area is meter square. Actually this is 0.15, so I can write the value to 3 digit 0.153 watt per meter square. So this is the answer for the first intensity. Let's I take this is I1. In the similar way, I have to calculate the intensity for the radial distance of 6 meter. So let's one more time calculate the value of the intensity for part B. I have to use the same rule I2, which is equal to P over A. So this time I have to use the R value as R2 square. Therefore A, which is equal to 4 pi R2 square. So again I have to substitute the value here. Therefore the intensity for this case, which is equal to the power value is 12 watt over 4 pi R2 square, which is equal to 12 over 4 pi multiplied by 6 square. Let's see what is the answer for the second case. 12 over 4 pi 6 square. I got the answer as 0.0265, and the unit again as watt per meter square. So again I want to write the value in terms of 3 digit. So therefore the intensity for this radial distance 6 meter is 0.027 watt per meter square. Clear? That's it. Thank you.